I am going to discuss what super 11 question from analog circuit, and all these questions are very important, right? And hope your preparation is going well. Are you ready to solve some questions? Very basic questions with some concept, right? And yes, we may expect this type of questions. That is for quick revision, okay guys? Then, and this is my introduction for new students. Myself Sanjay Rathi. I am having around 21 plus years of teaching experience. I have qualified and selected for engineering services exam that is conducted by UPSC, and I have mentored more than 1 lakh students for these exams. Okay, so this is my introduction. Now we have 2 days, right? Not a second, third, fourth, right? So you have the paper on 5th. Second, for electrical student first half, and for electronics student second half. I think, are you ready? Everyone, how's the JOS? So don't worry about the results and so on. Prepared है ना सबके सब आप लोग? पूरे जोश में है ना पेपर को लेकर? तो चलिए क्विक रिवीजन करते हैं लास्ट टाइम में. And we are going to conduct what full exam analysis, check out answer keys and expected cutoff just after your exam, right? And so please subscribe our channel so that you will get the notification, and just after the exam join the session, right? And then my dear friends, that is the date is what? 4th and 5th Feb. For computer science it is the 4th Feb, for mechanical it is the 4th Feb, and then what on 5th Feb for electrical students and for electronics student. Okay, this is for electrical, electronics and computer science branch. To subscribe our channel. Now my dear friend, that is the first diagram on what BJT, very simple one, very basic concept, integration of BJT and the diode. And what is the question? Everyone please read this question and step by step try to solve, right? And don't expect anything. Please share the link of this session so that student will join. Okay. In the circuit shown, assume beta is equal to 100, RB is equal to 50 kilo ohm. This is the RB, that is 50 kilo ohm. VB is equal to 0.7 volt. The drop across the diode is 0.7 volt when it is forward bias. RE is 200 ohm. 200 ohm. VT is 5 volt. VT means this voltage. VT is 5 volt. VCC 10 volt. RC 2 kilo ohm. RD 5 kilo ohm. This RD is 5 kilo ohm. Find the minimum value of Vx for which diode will remain in forward bias condition. Diode will remain in forward bias condition. That is a very simple question. Integration of the diode and what? BJT. So everyone try to solve the answer, and before my solution, try to give the answer for this question. Okay? तो चलिए बनाइए जरा, जब तक मैं इसे सेट कर लूं. Right. Okay. Now, please note this data. 0.7 VD is 0.7 volt, RE is equal to 200 ohm, VT is 5 volt. What should be the approach, right? And that is very important during exam, right? Suppose it is BJT. What is asked here? Diode will remain in forward bias. What is the value of the Vx? What is the minimum value of Vx for which this diode will remain in forward bias? So who will make it reverse bias? My dear friend, this is the diode is connected, battery is connected. Now, there will be a current in this direction because of this battery. But try to understand, when this is a transistor, there will be the current IB. Let this current is IC. And here the current is IC plus IB. And this IC plus IB will flow in this direction from negative side to positive side. What about the diode? Let this current I is in positive direction. And this current IC plus IB, it is in negative direction. So what is the resultant current through the diode? The top of the current is not seen. It is not visible, everyone. Is it visible or not? Tell me. Question is visible, everyone. In the circuit shown, assume beta is equal to 100, RB 50 kilo ohm, VB 0.7, VD 0.7, RE VT 5 volt, VCC 10 volt, RC 2 kilo ohm, RD 5 kilo ohm. Find the minimum value of Vx for which diode will remain in forward biased. That is the question. Yes. So किसने कहा था? Joha, please refresh your system or please watch this. Everything is fine, I think. Now, what is the? देखो सबसे पहले ना, what should be the approach? How to solve this type of question? Remember, when the diode is forward bias, it is asked, then what is the current from P to N side and what is the current from N to P side? This is the current is N to P side. So what is the resultant current through the diode from P to N side in this direction? The resultant current will become I minus IC plus IB. And this current should be equal to what? 0. Should be greater than 0, equal to or greater than 0. If this current is 0, then the diode is what? Forward bias. Now, in this question, we have to find the value of I, we have to find the value of IC and IB, then we can solve this question. So what is the I? You can write the KVL in this loop. When I am writing the KVL, it will become minus Vx. This is the minus Vx plus minus Vd plus I into Rd. I into Rd, that is equal to 0. From this you can say I is equal to Vx minus Vd upon what? Rd. Vx minus Vd upon Rd. That is the equation number 1. This is the equation number 2. Okay. Equation number 1 or equation number 2. Okay. Now tell me, right, this is I think now it is clear. Okay, please try to solve this question. Ab, how to find the IC plus IB? Let the BJT is in active region. Let the BJT is in active region. BJT is in active region. If the BJT is in active region, so what is the IC is equal to beta IB? So what is the current here? 1 plus beta times of IB. What is the current here? IB. Write down the KVL from this point to this point. You will get minus VT plus IB into RB plus 0.7 plus 1 plus beta times of IB into RE minus what? 0.7. What is the drop across the diode? Minus 0.7, that is the VD, is equal to 0. This 0.7 is cancelled out, and what is the IB is equal to VT divided by RB plus 1 plus beta times of RE. 1 plus beta times of RE. What is the value of the VT? It is given in the question. What is the value of the VT? VT is equal to 5 volt. This VT is 5 volt. RB is given as right, watch this diagram, 50 kilo ohm. RB is given as 50 kilo ohm. Beta is given as 100, and this is cancelled out, and it is given as 200 ohm. 200 ohm means 0.2 kilo ohm. So it will become VT 5 volt 50 plus beta. Beta is given as 100, it will become 101 into 0.2 into 0.2, 101 into 0.2, because it is a 200 ohm. So what is the answer? Tell me, what is the answer now? Now you can find the value here. Okay, please try to solve this question. Once you will get the value of IB, right, you can find the value of IC, beta IB. 100 times of IB. Okay, IB or IC, now you have the idea about the IC and IB. Then from this equation, ID is equal to, what is the I? I is equal to Vx minus Vd by Rd. We have to find the Vx. We have the value of the Vd 0.7. Vx minus Vd 0.7 upon Rd. What is the Rd given in the question? 5 kilo ohm. 5. minus IC plus IB. Get the value of IC plus IB from this formula. Get the IC and then the IB. Add these two values, and then finally put here with multiplication with what? You have to check this minus IC IB, and that should be greater than or equal to what? 0. Okay. I'm giving you the 1 minute. Give me the answer. Otherwise, with calculator, I will give the answer. Sir, why drop not include drop across what? What is not included, my dear? Yes, you can ask your doubt. VB is 0.7 volt. VD is 0.7 volt. They will cancel each other. They will cancel each other, my dear students. Try to understand. This is, if suppose I am writing the KVL, so what is this? Right. Minus VT plus what? IB into RB. IB into RB plus what is the drop across this? VB plus what? IC plus IB into RE plus what? Minus VD. This is minus VD is equal to 0. So minus VD and VB both are 0.7 volt. That's why they cancel each other. And now you are directly you can write this formula, right? Or IC plus IB, because IC is equal to what? Beta IB. Directly in exam hall, directly write IC plus IB in active region. It will become 1 plus beta times of IB. 1 plus beta times of IB. I think now it is clear. Okay. That is a simple approach. Okay then. तो give me the answer. Give me 1 minute. मैं थोड़ा कैलकुलेटर देख लूँ और आप बताइए जब तक आंसर क्या होगा आंसर. Everyone tell me what is the answer. Next slide ना. Okay. बोलिए जरा क्या है आंसर. IB 0.0712 मिली एम्पियर. डायरेक्टली फाइनली आंसर दे दीजिए. अब तो IC प्लस IB. अब तो एग्जाम 2 दिन बचा है. पूरा हिंट मैंने आपको कर दिया. अब तो मुझे लगता है आपको सीधा आंसर ही बता देना चाहिए. व्हाट विल बी द आंसर फॉर दिस पर्टिकुलर क्वेश्चन. राइट. मैं तो आपको सीधा आंसर ही बताऊंगा. Around 17 point something. Tell me, are you getting this type of answer? 17.42 volt. Okay, check this. I think now it is clear, everyone, that hint is clear to you. Okay. So what is the approach? Try to understand. First of all, when the diode will be forward biased, so that is the current in the from P to N side, and IC plus IB, it is the current from N to P side. Then let the BJT is in active region. Find or write down the KVL here. Once you will write the KVL, you will get the value. Okay. And then, my dear friends, second important thing, how we can find I? Write down the KVL in this loop, get the value of I, and the resultant current ID. I minus IC plus IB should be greater than 0. Okay. Then when I am writing the KVL, I can find the value of IB. Once you will get the value of the IB, that is the IB. Okay. From IB you can find the IC. IB plus IC, and I think you will get the IB plus IC. It is a very easy formula. Okay. Then put here in this formula, and finally you will get the Vx. It should be greater than or equal to. Greater than or equal to. Any doubt? Rupesh, Ravi Shankar, Ashok, anyone. Now, second important thing, we are assuming that let the BJT is in active region. Actually, it is in active region, yes or no? How we can check, my dear friends? Tell me. If the BJT is in active region, then my dear friend, VCE should be greater than what? VCE set. VCE set. It should be greater than what? VCE set. So finally, once you will get the value of the IC plus IB, then you have to verify it, whether it is in active region, yes or no, because we are assuming that let the BJT is in active region. Suppose if it is not in active region, then then it will create problem. It should be greater than 0.2 volt. If nothing is given, it should be greater than 0.2 volt. In that case, finally, once you will get the IC and IB, write down the KVL from this point to this point and find the value of actual value of the VCE. So when I am writing the KVL, so what is the value of the VCC given in the numerical? VCC is given in the numerical is 10 volt. 10 volt. You can write the KVL 10 is equal to, this is the 10 volt, IC RC. IC into 2 kilo ohm. RC it is given as 2 kilo ohm. 2 kilo ohm. Now plus VCE. Plus VCE plus what? 1 plus beta times of IB into RE. RE. Already we have the value of IB minus VD. Minus VD. VD means 0.7 volt. Now from this you can find the value of VCE. 10 minus 2 times of IC plus 1 plus beta times of IB into RE, that is the minus. That is not plus, this is minus. Plus 0.7. This will minus will become plus 0.7. If you are getting the VC greater than 0.2 volt, it is not in active region. Not in saturation. Not in saturation, it is in active region. So 99.99% chance it will be in what? Active region. Okay? It will be in what? Active region. You can directly solve it. And finally, you can verify it. Finally, you can verify it. You have to apply the KVL from this point to this point. Finally, from this point to up to what? Ground. Up to ground. Okay, Chinmay? From this point to this point. Initially, we are applying the KVL in this loop to find the value of IB. And first, to find the value of I, we are applying the KVL in this loop. In this loop. 3 KVL. Everything is over now. Yes, active region. Okay. You can verify it. You will get the value greater than what? 0.7 volt. Around 3.49 volt. 3.49, that is the value of VCE. Maximum every question related to BJT will be in active or saturation. No, Raghuram. No. Don't be biased. Don't be anticipate this type of thing. Na? Otherwise, you will think about the active region, or in exam, it may be in what? Saturation region. Don't be biased. Itna technique, itna already we have given each and everything about the BJT. Then if it is in active region, again you can solve. If it is in saturation region, again you are able to solve this question. Okay. So 90 means when the unknown register or this type of question is asked, to 99% case, this is a variety of question. Okay. But in this case, mean focus on what, how. If suppose it is fine, if it is in saturation region, then what? Then what? If it is in saturation region, my dear friend, suppose this value is less than 0.2 volt, then what should be the approach? The approach will remain same. The approach will remain same, my dear friends. But what is the change here? Then if it is in saturation, my dear friend, then if it is in saturation, then you have to fix these two values. No doubt in numerical, they will provide you the VCE set and IC set. What is this? 0.2 volt. What is this? 0.7 volt. Normally, now these days, they will give the saturation value 0.7 volt. But this time, IC plus IB. It is not beta IB. Here the current is IC, here the current is IB, and you have to write the 2 KVL. 1 KVL in this loop, 1 KVL in this loop, and you have to find the value of IC plus IB. IC plus, I will upload, and at the end I will give the password also. You have to write the KVL in this loop. You have to write the KVL in this loop. You will get the 2 equation. From these 2 equation, you will find the value of IC and value of IB. And then, my dear friend, you have to use the again same formula, this formula, to get the value of what? Vx. Easy? Kar loge? Yes, everyone. Now I am going to second question. This is a very, very, very important question on BJT. किसी को भी doubt है तो पूछ लीजिए. Any doubt? Now next question. Right. This is the first one. And my dear friend, probability is high because it is a standard diagram from Millman-Helkias. Millman-Helkias. Biasing and stabilization, and this is the diode biasing. We can expect one what MSQ on this. MSQ on this diagram. This is called diode compensation, and it is used for what? Silicon transistor. It is used for silicon BJT. This is the standard diagram. Okay. In my paid classes already I have covered all these things. Values of the solution. Ravi, you can verify VC, you will get 3.409. Check my calculation. Otherwise, according to my calculation, VC is a 3.409 volt, nearly equal to. If you find any difficulty, please inform me. Or around Vx is equal to 17.42 volt. Means it is nearly equal to 18 volt. They will give the answer in the range from 17 to 19 volt and so on. Right. Yes. Now, compensation, diode compensation technique. That is the answer. Next one. Now, my dear friends, again, that is a standard diagram for clipper, 3-level clipper, 3 diodes, right? 3 diodes, but what is asked here? Normally, they will not give you the complete explanation of the 3 diodes because it will become very lengthy, but this is a very, very easy question. What is asked here? Assume that the diode are ideal. The range of the VI is from 0 to 50 volt. Range of the VI from 0 to 50 volt, okay. 6 volt battery is connected here, 20 volt battery is connected here. Find the minimum and maximum value of the output voltage. Try to give me the answer. Okay, tell me. What is the minimum and maximum value of the output voltage? Right. In this question, to find the minimum, and what is given, assume the diodes are ideal. Ideal diode means once it is forward bias, it will act as short circuit. It is reverse bias, then it will act as open circuit. That is the meaning of the ideal diode. You have to find the minimum and maximum value of the output voltage. Okay, only. Right. So, for minimum value, you have to put the minimum value of the input. What is the minimum value of the input is given in the question? 0 to 50 volt. Now, when I am putting the 0 volt here, what about the diode D3? What about the diode D1 and what about the diode D2? Right. My dear friend, because it is 0 volt, the voltage at this point is very high, 6 volt. Right. And this is the 20 volt. So, first of all, always check the highest battery, that is the 20 volt. Because of this 20 volt, that is what? This diode is off. D2 is off. We can say D2 is off. Now the second highest battery is 6 volt. Because of this 6 volt, this is the only D1. There is a path 5 kilo ohm. This diode is on. D1 is on. And because of this 6 volt, here it is 0 volt. Initially it is 0 volt. So there will be the positive voltage and D3 is off. D3 is off. So it is the initial assumptions. Okay. Then make a proper diagram. This diode is off, remove it. This diode is on, it will act as short circuit. This diode is on, remove this branch, remove this branch. Now, what is the V0? 5 kilo ohm here. This is 5 kilo ohm, this is the 6 volt. This VI is disconnected here, no use of 2.5 kilo ohm. My dear friend, voltage division rule and you can find the V0. So what is the V0? V0 minimum is equal to 5 divided by 5 plus 5 into 6, that is nothing but 3 volt. So this is the minimum value of the 3 volt. Raghuram, yes. Ravi, like I see, D1 is on, yes. D1 is on, D3 is off. Once you will get the idea about the diode, it is a question of what? Network. It is a question of network only. Okay. तो चलिए ये हो गया और याद रखिए एनालिसिस होने वाली है 4th and 5th Feb को. 4th and 5th Feb just after the exam for computer science, for electrical, for electronics. तो subscribe our channel so that you will get the notification. तो यार रिजल्ट की परवाह मत करो, अभी तो बस ध्यान लगाओ. ये हो गया क्वेश्चन. उसके बाद आता है सेकंड डायग्राम. Try to understand how to find the maximum value. Now, maximum value, how we can find the maximum value. But try to understand, this is our assumptions, na? This is our assumptions that this diode is on, that diode is off. You have to verify your assumptions. You have to verify your assumptions. Right. कैसे? For example, we are assuming that this diode is off. Finally, you are getting the 3 volt here. Finally, you are getting the 3 volt here. My dear friend, here we are having the 3 volt. What is about the D3? On one side, we have the 3 volt because there is no drop across 2.5 kilo, here 0 volt. And definitely this diode is off. Our assumptions is correct. Similarly, it is a 20 volt battery. So here we are getting the 3 volt. Here it is a 20 volt. So 20 volt is greater than 3 volt, and that's why this diode is off. Our second assumption is also correct. You have to verify it. You have to verify it, and that's why the minimum value is 3 volt. Finished. Now in second case. For maximum value. For maximum value, put the 50. Put the 50 here. When I am putting the 50 here, 50 volt. Now definitely the 20 volt is less than 50 volt, 6 volt is less than 50 volt, and that's why this diode is on. Now the 50 volt is very high and 6 volt is very low as compared to 50, and it is connected to positive terminal, and that's why this diode is off. And 50 volt is greater than 20 volt, it is on the negative side. Let this diode is what on. So this is on, this is off, this is on. You have to make a proper diagram then again. So what is the diagram here? This diode is on. This diode is off. Remove this branch. 20 volt is on. 10 kilo ohm. And this is the 5 kilo ohm. This is the 5 kilo ohm. This is the V0. This is the V0. 2.5 kilo ohm, and that is the VI. And what is the value of the VI? Maximum 50 volt. Right? Okay. Now simply KCL. KCL V0 minus 50 divided by 2.5 plus V0 minus 20 divided by 10 plus V0 divided by 5 is equal to 0. Take 10 as a LCM. 4 V0 minus 200 plus V0 minus 20 plus 2 V0 is equal to 0. This 10 will become 0. 4 plus 5, 6, 7 V0 is equal to what? 220. So what is the V0 is equal to? 220 divided by 7. What is the 220 divided by 7, everyone? यार comments box में जल्दी से comments दे दो. 220 divided by 7, 31.42 volt. 31.42 ohm. So we are getting the output 31.42 volt. And my dear friend, at this point, if this is the 31.24 volt, definitely this diode is on. This diode is on because 20 volt is less. And if here it is the 31.42, here it is only 6 volt, then definitely this diode is off. And here we have the 50 volt, here we have the 31.42, means this diode is on. Our assumptions is correct. Our assumptions is correct. What is the maximum value? 31.42. Easy. Okay, it will become what? Very lengthy question, and that's why they will ask only maximum and minimum value. It is a maximum and minimum value. Okay then. Oh, 31.42. One student is asking, giving the answer 10 pi, sir. Okay, 10 pi is also correct. But right. Yes, assumptions and checking is better before making the marking the option. Yes, that is the important approach. Okay, next question. Next one, without any delay. PDF will be available on my Telegram channel, that is Electronics by Sanjay Rathi. So I will share the link. I will give you the password at the end of this session. Please remind me. Next one, very important question again. Now, very fast. My dear friend, in this type of question, they will ask, because there is only 2 diodes. There is only 2 diodes. That's why they can ask what is the transfer curve for this. For electrical students, for electronics students, number of times question on clipper with transfer curve. So what is the transfer curve? First of all, give me the maximum and minimum value. But what is the hint to solve this question? Normally, in case of transfer curve, they will give you the 4 option. MCQ type question. MCQ type question. If we have the 4 options, I am not giving you the options, no problem. If there will be the 4 options, then my dear friend, first of all, find the maximum and minimum value of the output, because that range is given from -30 to +30. And from the 4 option, we can check what is the maximum and minimum satisfied by which diagram. If only one diagram satisfied the maximum and minimum, then we can directly find the value. That particular answer is what correct. Otherwise, directly you have to check. So that will be the approach. So how we can find here? Now, 1 minute. So what is the approach? Okay. What is the minimum value? Minus 30. Put here minus 30 to find the minimum value of the output. Then because of this minus 30, this diode is off. Because of this because this is negative 10 volt, this diode is also off. Both are off. Give me the answer. What is the output voltage? 0. So minimum output voltage is 0 volt. Minimum output voltage is 0 volt. Second, what is the maximum output voltage? Maximum output voltage, you have to apply the 30 volt. Right? 30 volt. When we are giving the 30 volt, this diode is on. This is on. It will act as short circuit. And because of this 10 volt, because it is a 30 volt, this diode is also on. We have to verify it. 10. This is 10. What is the maximum output? 10 volt. 10 volt. Okay. Now, here it is a 30 volt. Here it is a 10 volt. Right. What is the voltage? Because if suppose once you are assuming that like this diode is off, my dear friend, the voltage at this point will be 20 volt. Right. And that is the case. So our assumptions is correct. Both the diodes are on. This diode is on as well as that diode is on. And the output maximum voltage is what? 10 volt. Okay, that is a very easy question, 1 mark question. If suppose the transfer curve is asked, then it will become what? 2 mark question. If the transfer curve is asked, then it may become 2 marks question, MCQ with negative marking. So negative marking means if you have to draw the transfer curve, then you have to make the proper table here. So what is the proper table? VI, diode D1, diode D2. Not. Otherwise, you can verify from the answer. Once you will get the maximum and minimum value, verify the answer. If the one particular answer will satisfy, directly you can put the answer. Directly you can put the answer. Okay. Then, roughly we are getting this type of answer. Because it is a lowest value is 0 volt. Highest value is what? 10 volt. Here you will get the constant value for 10. And there may be the slope in the change in the slope from 0 to what? 10 volt. Because there is only 2 diodes, there will be the 2 breakpoints and you will get this type of answer. Okay. Now, but how we can get the exact one? Minus 30 is less than VI is less than or equal to. This diode is off. This diode is off. Already we have calculated the output 0 volt. No need to verify it. Now, when this diode is off, this diode is off. This will act as open circuit. This diode will act as open circuit. Right. What is the output? 0 volt. So what is the voltage? VI. What is the voltage at this point? 0 volt, because output is 0 volt. This is the 0 volt. When VI increasing, the VI, and when we increase VI is greater than 0 volt, diode D1 will on. The first breakpoint is 0 volt. First breakpoint is 0 volt. 0 is less than or equal to VI, less than or equal to. Now the D1 is on, this is off. Draw the second diagram. This is on, this is off. Everyone, please find the output voltage. This is the 10 kilo ohm, this is the 10 kilo ohm, this is the VI. Always you have to find the output in terms of VI. It will become 10 divided by 10 plus 10 into what? VI. That is nothing but VI by 2. It is the VI by 2. Finally, you will get the VI by 2. Now, if this is the VI by 2, when this diode will on, we have to check the D2. So, on the positive side, the voltage is VI by 2. On the negative side, it is a 10 volt. So, when this VI by 2 is greater than or equal to 10 volt or VI is greater than or equal to 20 volt, diode D1 will on. D2 will on. So the break point is 20 volt. And the 20 is less than or equal to Vi less than or equal to 30 volt. This is on, that is on. Already we have calculated when both the diodes are on, what is the output? 10 volt. Maximum output is 10 volt, already verified. Now, what will be the question? What is the slope? What is the slope between these 2 points? That may be the question, or they will ask you to draw the transfer curve. So what is the transfer curve here? Now, I will show you that question. Okay. So, new students, please don't worry about this question. Very easy question. Write down this table. From minus 30 to 0, output is 0 volt. 0 to 20, output is Vi by 2. And 20 to 30, output is what? 10 volt. Always they will give you the diagram with the slope 1. This is the slope 1. 45 degree, that is the slope 1. Now, what are the breakpoints? First breakpoint is 0. And second breakpoint is 20 volt. This is the 20 volt. This is the 20 volt. Right? And this is the Vi, that is V0. This is called transfer curve. When the input is less than 0 volt, output is 0. From 0 to 20 volt, what is the slope? Vi by 2. The slope is half. And that is the case. Or when it is 20, it is fixed at what? 10 volt. Fixed at 10 volt. And that is the transfer curve. That is the transfer curve for two-level clipper. Two-level clipper. Any doubt? Any doubt, students? Right. Ye ho gaya, that is the second one. So this is the about the clipper. They may ask from last 4 to 5 years. There is no question from the clipper that it, we may expect this time. We may expect this time question on clipper. Okay. Next one. Okay. And that is on what already I have asked one question on biasing. Now this is the question on what? Amplifier. Okay. Give me the answer. Everyone. Consider the following circuit. Find the V0 by Vs. You have to find the mid-band voltage gain. Sometimes they will ask, find the mid-band voltage gain. Mid-band voltage gain. If this is asked, again you have to calculate the AVS. AVS, that is the V0 by Vs. They will change the language only. Mid-band voltage gain. What is RS? This time RS is given. No capacitor is connected here. Only RS is given 10 kilo ohm. If the capacitor is there, always remember, during AC analysis, capacitor act as what? During AC analysis, capacitor act as what? Short circuit. Here that is not mentioned in the syllabus, but there may be indirect question on that. What power amplifiers? Okay, we will solve one question on that. But indirect question already electrical branch, that was very conceptual question. I am going to find the efficiency of that. Okay. So please everyone stay tuned with me. At the end, you are going to get what unique type of question. Right? No doubt. We are using the same type of concept, but little bit different. Okay. Tell me. Mid-band voltage gain V0 by Vs. RS is given as RE. This RE is given as 2 kilo ohm. But here 1 minus BRE, there is a just it is behave like what? Potentiometer. And RL. And B is given as 0.2. This small b is given as 0.2. Small RE. What is the small RE? Dynamic resistance. They will give you this type of formula. Is equal to what? 25 ohm. 25 ohm means what? 0.025 kilo ohm. Convert it into kilo ohm. Okay. RE is given. Beta is given as 50. You have to find the V0 by Vs. Means which model we can use? Which model we can use, my dear friend? RE model, T model to find the gain. RE model or T model for to find the gain. Okay. Now, because RE is given, then RE model means this is alpha I or what? This is the IC. So IC is given as alpha I or we can say beta IB. Both are correct. Beta IB, both are correct. Now here we are having the beta base terminal, or here we are having the small RE. Okay. Now this is the emitter terminal, this is the base terminal, and this is the collector terminal. This is called RE model because RE is given in the question. Now this is the emitter, this is the base, and this is the collector. During AC analysis, VCC act as 0. That's why the value of the VCC is not given. This is the VS signal, V0 here signal. Collector, we are getting the output. It is a common emitter configuration. Common emitter configuration. Now, from collector to ground, sorry, first of all, emitter to ground, RE is connected. Emitter to ground, connect RE. Just like a potentiometer. Now, make a proper ground here. This is the ground. Okay. From collector to ground, RL is connected. Collector to ground, connect RL. This RL is connected here. Here we are getting the V0. Okay, this is the V0. I think that diagram is, because very important one is what? Draw the diagram. Otherwise, after that you have to apply the network, concept of network only. This is the RS. This is the VS. This time this VS is not connected to ground. This is connected here, my dear students. This is connected here. And what is the value of that? 1 minus B times of RE. 1 minus B times of RE, capital RE. Or this is the RE. Now, what is the value of B? No need to consider this one. This is the BRE. Right. This is the value. Now, what is the current here? This current is IE, or IE is nothing but 1 plus beta times of what? IB. 1 plus beta times of IB. And what is the current here? Base current IB. Diagram is over. If the diagram is over, question is over. Any doubt, then you can ask. Any doubt, then you can ask. You can find the alpha also, or you can directly write the beta IB. Both are correct, Ravi Shankar. Both are correct. Both are correct. If I want the answer in terms of what IB, because there is RS is given, and that's why I have using the formula beta times of what IB, otherwise alpha beta upon 1 minus 1 plus beta. You can find the value. Okay. Now, ready? Chal. Up, simple, apply the KVL. KVL, where the KVL? KVL means in this loop, what is the V0? Directly you can say, give me 1 minute, no? No, I'm going to apply the KVL here. Okay, what is the V0? V0 will become minus beta IB into RL. And what is the VS? VS, write down the KVL, IB into RS plus 1 plus beta times of IB into what? RE plus 1 plus beta times of IB into 1 minus beta B times of what? Capital I. And that is the value. Divide it, V0 by VS. IB cancel, and answer is what? Minus beta RL upon RS plus 1 plus beta times of 1 plus beta IB already cancelled. It will become small RE plus 1 minus B times of capital R. Okay, and now put the value. What is the given beta? Minus 50. What is the beta given in the question? 50. Into RL. What is the RL given in the question? RL 3 kilo ohm. Divided by RS 10 kilo ohm. RS is given as 10 kilo ohm plus 51. Beta is 50. Small RE only 0.025. Plus B is given as 0.2, it will become 0.8 into RE. What is the capital RE given? RE. RE is given as 2 kilo. Now find the gain. Find the gain of this system. So I think now it is clear. Now it is clear, everyone. Very easy. That is the use of what model? That is the use of small signal model 1.61. Nearly equal to 1.61. It is a numerical answer type question. Numerical answer type question. So that is the use of what? small signal model. Okay, next question. So some students are new here. I think you are getting the answer. Okay, next one. This is a Super 11 series. Now I am going to discuss what fifth question. If the Ravi Shankar, if the model was forgotten, then you can use what shortcut? What is the answer for this one? फिर एक बात बताओ, अभी भूल जाओगे फिर एग्जाम में क्या करोगे? चलो कोई बात नहीं. What is the shortcut for this question? Already I have given V naught by Vs when the Re is given, that is given by minus Rc by Re. Okay, but this time we are not using the complete Re. We are using the 1 minus beta times of Re. That is our portions, upper portion, and that's why what is the approximate answer? Minus Rc by 1 plus minus b times of what? Small r, capital Re. That is the approximate answer. What is this? RL is given as 3. This is the 1 minus 0.2, and it is a over approximated answer. Now what is the small Re? Small Re is given as 2 kilo. It will become minus 3 into 0.8 into 2, that is 1.6. So minus 3 divided by 1.6. What is the answer, everyone? And that is the overestimated answer. Now you can check your answer also. So 3 divided by 1.6. 3 divided by 1.6. And what is the RC? Ek minute. What is the RC given in the question? RC. RL means RC means RL. RL is given as 3 kilo. Okay. Right. 1.875. But my dear friend, what is the problem in this? No doubt, it is a overestimated. Already I have given a overestimated. Means result will be less than that. Yes, we are getting the result less than that. Minus 1.61. But my dear, numerical answer type question. In that formula, we are not considering the RS. We have to consider the RS. Actually, we are considering the small Re also, but negligible. Small R is negligible. But you have to consider the RS. Okay? Is it clear? But we can check our answer is correct, yes or no. Because answer will be always less than 1.875. Answer will be always less than 1.875. That is the approximated answer. Okay. Yes, your calculation is correct. Now next one. Okay, fast. Give me the answer for this one. The transistor shunt regulator shown in the figure. My dear friend, they will ask the question already in my question answer series. Already I have given the hint to quickly try to solve this question. Transistor shunt regulator shown in the figure has regulated output voltage of 10 volt. This time I think there may be the question on what voltage regulator with the transistor. Minus 1 means 180 degree phase shift because it is a common emitter configuration. Transistor shunt regulator shown in the figure has a regulated output voltage of 10 volt. This is 10 volt is given when the input varies from 20 to 30 volt. The relevant parameter for the Zener diode and the transistor, it will be given in the question. Vz is given as 9.3 volt, Vb is given as 0.7 volt, Rb is given as 10 kilo ohm, this Rb is given as 10 kilo ohm, beta is given as 100, beta for the transistor is given as 100. Maximum power dissipated in the Zener diode and the maximum power dissipated in the transistor is. What is the value of the power dissipation across the Zener diode and transistor? How many digits? They will ask you up to 2 decimal places, right? Or sometimes they will give you the range. In this type of questions, they will give you the range, right? They will give you the from this range to this range. Okay. अब ऐसा नहीं है कि वो दे देगा range from 1.5 to 1.8 some 1.9. They will provide you the range that is from 1.5 to what 1.7. So answer is what 1.61, and that is the case. 2 decimal places, right? Now this is a question on what voltage regulator. So how we are going to solve this question? Again, my dear friend, normally RB is not given in the question, but in this question RB is given. Then what will happen? Let this current is I. Everyone try to understand the concept, how to solve this question. What should be the approach during exam? Let this is I. Okay. What it is, know the I, then what is this? I is divided into IZ and IC. RL is not given. Sometimes they will give you the question RL. Remove the RL. Remove the RL so that IL will become 0. Because in that case, you are going to get the worst condition. In that case, you are going to get the worst condition, my dear students. What is up? During power dissipation, let the complete power, current will pass through the Zener diode and what IC. What is the worst condition? If it is not given, okay. If it is given, then remove. then IZ and what IC. IZ is again divided into what IB and what, like this is the I des. So what is this? I is divided into IZ plus IC, and that IZ is divided into what? IB plus I des. Okay. Since transistor in active region, always in this type of question, this is in active region because it is 10 volt is given, VC is greater than what? 0.2 volt. Definitely it is in active region. So IC is equal to beta IB. Okay. And Zener diode is in breakdown region. So what is the drop across the Zener diode? 0.7 volt, 9.3 volt. And what is this VB? 0.7 volt. And that's why V0 is equal to VC is equal to 0.7 plus 9.3, that is the 10 volt. Now what is asked in the question? Power dissipation across the transistor, that is nothing but VCE into IC. Power dissipation across the Zener diode, that is the VZ into IZ. Everyone here solve karaya maine question. Please give me the answer in the comments box. Answer in the comments box. Okay. VZ into IZ is the power dissipation across the Zener diode, right? There may be one question only. I have put the two question, but in exam they will give you the one question, or it may become what? MSQ also. It may become MSQ also. Okay. Now, to find the value of IZ and IC, we have one equation. You have to find the value of I first of all. I will become maximum. Always when we are calculating the power dissipation, always take the maximum value. Vi max minus V0 upon what R? 30 minus 10 divided by, that is 20 ohm is given, you will get 1 ampere. Okay, 1 ampere. Now, once it is 1 ampere, we have the idea. This 1 ampere is divided into IZ and IC, and IZ is divided into IB and what? IDES. What is the IB? What is the IDES first of all? This voltage is fixed 0.7, and therefore IDES will become VBE upon RB. 0.7 upon RB. What is the RB? RB 10 kilo ohm. Okay, this is the 10 kilo ohm. It will become 0.07 milliampere. Negligible current, that is called bleeder resistant. It will pass the extra current. If the IB is very high, then it will pass the extra current. But this is a, again when I am choosing the RB is equal to 10 kilo ohm, that is the negligible current through this one. Okay, that is the approach how to solve. Then you have the formula, right? IZ is equal to IZ, it will become IB plus 0.07 milliampere. Okay. Now what is the I? I is a 1 ampere. 1 ampere, remember na, 1 ampere means 1000 milliampere. 1000 milliampere I. IZ is equal to IB plus 0.07 plus IC. What is the IC? Beta IB. What is the value of the beta given in the question? Beta 100. 100 times of IB. Find the value of the IB from this. 1000 minus 0.07. 0.07 is negligible. 101. Get the value of IB. Get the value of IB, everyone. What is the value of IB? So 1000 minus 0.07 divided by 101. 9.9 nearly equal to milliampere. 9.9 milliampere. What is the value of the IC? Beta IB. 9.9 into 100. Check my calculation also. Check my calculation also. 1000 minus 0.07 divided by 101. Okay. Yes. Now that is the value. 990 milliampere. Okay. Right. This is the value of IC. Now what is, once you have the value of the IB, you can find IZ. So what is the IZ? Now this time IZ will become IB. What is the IB? 9.9 plus what? 0.07. So it will become 9.97 milliampere. So what is the power dissipation across the Zener diode? VZ into IZ. 9.3 into 9.97. You can find the value. Easy guys, easy. 9.3 into 9.97, 92.721 milliwatt. Why milliwatt? Because this current is in milliampere. This is in volt, so this is in milliwatt. Easy. Now second one, what is the PT? VC into IC. VC is the 10 volt. It is given in the question. That is the VC, 10 volt. VC is the 10 volt. And what is the IC? IC already we have calculated 990 milliampere. My dear, it will become 990 watt, milliwatt. What is this? 9.9 watt. 9.9 watt. I think it is clear. To check my calculator, but that is the approach. That is the approach. It is asked in what? Remember, unit. And this is in milliwatt. This is in milliwatt. Because the power handling capacity of Zener diode is less. Power handling capacity of BJT is very, very high as compared to Zener diode. And that's why we are using the BJT here. That may be the question, my dear friend. Theoretical question, MSQ. Why we are using the transistor? Because in normal Zener diode, we are not having any transistor. It is a normal Zener diode. By using the Zener diode voltage regulator, why we are using the transistor? The power handling capacity of the transistor is high. That's why we can increase the range of what? VI, or we can increase the range of what? RL also. This diagram is preferable for high load variation as well as high line variation as compared to this diagram. Load variation as well as high line variation. Now, this is all about this diagram. No doubt. I think now approach is clear, everyone. Second, next question. We have to solve number of questions. I think now it is over. Now, what is the answer? I want answer from your side, because already I have taken. Sir, Zener diode is negligible, sir, high values. No. Zener diode, what the power dissipation across the Zener diode is very low as compared to when we are comparing BJT. Please tell me, everyone, what about this line? Big or small? Tell me, what about this line? Big or small? Here in MSQ, you have to give this type of answer. Tell me, what about this line? Big or small? We can't say, because it is a comparative term. So when I am putting this value, then we can say, yes, sir, it is very, very small, because it is a power dissipation across the BJT, it is the power dissipation across the diode. Then it is negligible. Otherwise, tell me, this is the Zener diode and this is the normal diode. This is the power dissipation across the Zener diode, and this is the power dissipation across the normal diode. Now, please tell me which one is high. Now, the power dissipation across the Zener diode is high. It is a comparative term. It is a comparative term. Yes, it is a precision. But what is the answer for this question? Precision rectifier 2 kilo ohm, 1 kilo ohm it is given. It is a 1 mark question only. Diode has a forward voltage drop of 0.7 volt. Means practical diode. Else it is ideal. If V in is minus 10 volt. On positive terminal we are giving a minus 10 volt. Then what is the V0? What is the V0? MCQ, negative marking, be careful. If it is 1 mark question, 1/3 negative marking. If it is a 2 mark question, 2/3 negative marking. It is a 1 mark question. Actually, it is a very easy one. Very, very easy one. Okay. Now, suppose these are the practical diode, right? So how we can solve this question? If it is a practical diode, then okay, watch this one. Oh, चलिए बताओ जरा, बताओ please, what is the answer? Just I want some space. Okay, no problem. Okay. Now at this point, this is the VA. Because of voltage at non-inverting terminal, phase shift is 0 degree. If it is negative value, this is the negative value. If it is the negative value, that is the negative value. Once there is negative value, try to understand. This is the minus 10. Because there is a 0 degree phase shift, this VA will be negative. Initially both the diodes are off, and that's why it is trying to moving towards what? Negative saturation. Negative saturation. But once it will reach towards 0.7 volt, negative 0.7 volt, what will happen? This diode will remain off because it is a negative value, and because negative is connected to negative terminal, this diode will be on. Now tell me, if this diode is on, there will be the negative feedback. So what about the diagram? This diode is on. This diode is off. This is the 20 kilo ohm, 22 kilo ohm, and this is the 1 kilo ohm, 2 kilo ohm. And what is the drop across the diode? 0.7 volt, minus plus, and what is connected here? 10 volt, minus 10 volt. Now, since there is a negative feedback, virtual short concept is valid. Vp is equal to Vn is equal to what? Minus 10 volt. But what is the current here? 0. Why the current is 0? Because that loop is open. RL is not connected here. So what will be the current? The current will be 0. So once the current will be 0, because this is a floating point, so the voltage at this point is minus 10 volt. So what will be the voltage at this point? Minus 10 volt. Minus 10 volt. Right. Okay. क्या समझ आ रहा है? Are you getting this question? Right. Minus 10 volt. Now what is the voltage at this point? At this point, what is the voltage at this minus 10? Minus 0.7. What is the voltage at this point? Minus 10.7 volt. Because this is the minus 10, this is the 0.7 volt. So what is the voltage? 0.7 minus 10 minus 10, 10.7 volt. So what about this diode? On the negative side, it is minus 10 volt. On the positive side, 10.7 volt. Definitely this diode is what? Off. This diode is off. Finished. That is the question. Very simple. Okay, next one. Next. You have to verify each and everything, okay, and then give the answer. This is on precision concept of precision rectifier, but it is a practical diode, guys. Now, again, and that is the question. That is the question on just BJT. Sometimes we have to give the approximation, my dear friend. This is MSQ. In the two-stage circuit shown, assume beta is 100 for each transistor. VC1 is equal to minus 4 volt, VC2 is equal to minus 6 volt, the value of the resistance and so on. If the very lengthy diagram is given, why I have chosen this type of diagram? If suppose very lengthy diagram is given, then always use what? Approximation. Always use the approximation. What is the beta given? 100. VC minus 4 volt, VC2 6 volt. This is the Q2. This is the Q1. This is the VCE2, this is the VC1. Why VC1, VC2 negative given? Because it is a PNP transistor. 17.8 kilo ohm, 2.82 kilo ohm, R, 3 kilo ohm, 1 kilo ohm. You have to find the value of R. There may be the one question only, find the value of R, or it may be MSQ. The given figure is an example of transistor compensation for Q point stabilization. Yes, there are compensation technique, my dear. What are the compensation technique? Diode compensation, thermistor compensation, transistor compensation, and most important one is what? Transistor compensation. In IC fabrication, we are using the transistor compensation. So this is the standard diagram for transistor compensation. That is right. Fixed bias circuit is more stable than the self bias circuit. What about the C statement? Right or wrong? It is the MSQ. Fixed bias circuit is more stable than the self bias circuit. Right or wrong? Third. Thermistor has positive temperature coefficient of the conductivity. Right or wrong? Right. Fixed bias circuits. In fixed bias circuit, there is no negative feedback. So self bias circuit is more stable, and that's why this point is wrong. The thermistor has positive temperature coefficient of conductivity. What about the D? Right or wrong? D. Thanks, sir. How many marks we can expect from analog electronics for electrical? My dear, in electrical sometimes it will play a crucial role. Okay, जैसे होता है ना कोई मूवी में, it is just like a side hero, but sometimes the movie will be hit because of the side hero, and that is sometimes in analog you may expect what, 8 to 10 marks, or sometimes it may be what, maximum 8 to 10 marks, but it will decide your rank. And you will get what, direct straightforward questions on BJT, MOSFET, operational amplifier. Thermistor has positive temperature coefficient of conductivity. My dear friend, right. D is the right statement. Why you are saying that wrong? Chinmay Roy, yes, you are correct. This is right. Array, conductivity it is written. Thermistor, what is the thermistor? Lightly doped semiconductor material. Lightly doped semiconductor material. Right. When temperature increases, new hole electron pair generated increases, and that's why conductivity increases, resistivity decreases, resistance decreases. So thermistor has positive temperature coefficient of conductivity, right? It is right. Right. Okay. Now next one. Now try to understand how to find the value of the R. Always remember, when the unknown register is asked, it is a DC analysis, and the value of the VC is given, the magnitude is greater than 0.2 volt, and that's why it is in active region. What is the VC2 given? Minus 6 volt. What is the VC1 is given? Minus 4 volt. Minus 4 volt. Now, first of all, always do the current distribution. This capacitor will act as open circuit because it is a DC analysis. What will be the current here? IB1. What is the current here? IC1. What is the current here? IB2. What is the current here? IC2. So what is the current here? IC2 plus IB2. Always you can neglect the IB2 in terms of IC2. Comparative term. What is the current here? Like this is the current IB1. So this current will pass through this IB2. And my dear friend, here this is the IC2. IC2 plus IB2 minus IB1. This is the IB1. This is the path of IB1. This is the path of IB1. This voltage is called VB. Always remember, for PNP transistor, VB will be negative. If they will give you the in a numerical, the magnitude of this is given as 0.2 volt. This data is missing. Please note this data. VB is equal to 0.2 volt. But mod is put here. Mod means, why mod? Because for PNP transistor, VB, value of VB is negative. Then already I have given what is the IC? Beta times of IB. 100 times of IB. And that's why IC is very, very, very greater than what IB. So you can neglect what? You can neglect what? IC plus IB means nearly equal to IC. So you can neglect the IB2 and IB1. It will become IC2 only. Right? Now similarly, what is the current here? IC1. This is the IC1. This is the IB2. You have to consider only IC1. What is the current here? IC1 plus IB1. IC1 plus IB1. Now only you have to consider the IC1. No need to consider the IB, negligible. But in this branch, what is the current? IB1. That this voltage is VA. This voltage is VB1. Once you will get the value of VA and VB1, you can find the value of R. What is the R? VA minus VB1 divided by IB1. VA minus VB1 divided by IB1. Okay, then what is the approach? What is the approach? Neglect the IB1 and IB2 as compared to IC2, but here you have to consider the IB1. So first of all, I will write the KVL from this point to this point, so that I will get the value of IC2. I can find the value of VA. The second, I will write the KVL from this point to this point to find the value of IC1. From IC1, I am going to find the IB1. And I will write the KVL from this point to this point, from this point to this point to find the value of what? VB1. VA known, VB1 known, IB1 known, you can find the value of R. So what is the KVL from this point to this point? Okay. Everyone please write the KVL fast. Then it will become minus 24 is equal to, minus 24 is equal to 8 times of IC2 plus minus 6, because VC1 is minus 6, plus IC2 into 1, IC2 into 1 plus IC2 into 3. 3 IC2. What is the IC2 will become minus 24 plus 6 divided by 12. 8 plus 9 plus 3, 12. It will become minus 18 divided by 12 minus 1.5 milliampere. Minus. Why we are reading the minus? Because it is a PNP transistor. The direction we have chosen the wrong direction. No problem. Minus means it is in upward direction. Okay. Once you will get this value, okay, then what is the VA? IC2 into 3. IC2 into 3, you will get minus 4.5 volt. Easy question, it is a 2-mark question, right? Approximation. IC2 is equal to what? Minus 4.5. Now, what is the value of VB? VB, you have to write the KVL from this point to this point. KVL from this point to this point. So, when I am writing the KVL, VBE plus what? IC1 into 2.2. IC1 into 2.2. But what is the value of the IC1? For IC1, write down the KVL from this point to this point. From this point to this point. Very easy. Minus 24 is equal to 17.8 times of IC1. Please neglect the value of IB2. You have to neglect the IB2. What is the VCE1? VCE1 is minus 4. Write the minus 4 here. Plus IC1 into 2.2. 2.2 times of IC1. From this, IC1 is equal to minus 24 plus 4 divided by 17.8, 2.2, 20. Minus 20 divided by 20, minus 1 milliampere. Now everything is known. Once you will get the IC1, what is the IB1? IC1 divided by beta. It will become minus 1 by 100 milliampere. And what is the value of the VB1? 0.2. You have to put the negative value because it is a PNP transistor. Mod is given in the question. 0.2 plus, it is again minus 1 into 2.2. You will get minus 2.4 volt. Everything will be in minus because it is a PNP transistor. And now, once you will get the value of VB1, already I have given. What is the method to solve this question? R. VA is known, VB1 is known, IB1 is known. So what is the answer? R is equal to VA. What is the value of the VA? Minus 4.5 volt. Minus of minus. What is the value of VB1? VB1. This is the VB1. Minus 2.4 volt. 1 divided by 100. This is the value of IB1. Again, that is also negative. This is negative. Negative cancel out. 4.5 minus 2.4, you will get 210 kilo. 210 kilo ohm. Okay, easy guys, easy question. No problem. Right. So again, it is an expected question. It is a standard diagram because it is fixed by, based on transistor compensation technique, and that's why it is important. It is a standard diagram. It is given in the standard textbook. 210 kilo ohm. That is the answer for this one. So always in this type of diagram, use the approximation. If the beta is given very large, you can neglect the IB as compared to IC, but you have to consider the IB here. You can't take IB 0 because you have to find the IB in this branch. And if the mod is given of VB, always remember for PNP transistor, it is negative value. Okay, the PDF will be available to you. Now next question. First, already we have solved the 7 questions. Next one. I think no doubt. No doubt. Okay. यार ये तो क्वेश्चन बड़ा इजी है. 8th one. Tell me what is the answer. Tell me minimum beta value can be what? अच्छा, for neglect to neglect the IB, right? If it is 50 times, again the IB, if it is the beta is 50, again the IC plus IB is negligible as compared to IC. When IC plus IB we are considering, right? If otherwise IB is alone, then you have to consider it. You have to consider it. Just after this question I will give the password. Don't worry Ravi Shankar. सब के सब बोलेंगे सर PDF डाउनलोड करके पढ़ लेंगे सुबह. अरे जल्दी से, बस 15 मिनट ओनली, नेक्स्ट 15 मिनट्स गाइस, नेक्स्ट 15 मिनट्स. अरे ये दैट इज ऑलरेडी सॉल्व्ड इन द क्वेश्चन, गिव मी द आंसर. It is MSQ. The output voltage of the given circuit. I have solved the diagram. This is a different question. MSQ 2 mark. Precision rectifier, half wave rectifier. What is the name of the circuit? Precision half wave rectifier. Ordinary silicon rectifier. Ordinary silicon rectifying diode means practical diodes. This is the 0.7. This is the 0.7. These two are the diodes, D1 and D2. Okay. So what is given? Vin and Vin. Okay, Vin 5 volt minus 5 volt. ठीक है, this is a very very simple one. First of all, put the plus 5 volt. How to solve this question? Standard question, 5 volt. Because of this 5 volt, because of 180 degree phase shift, what is the value of the VA? Negative. Once the negative D1, D2. D1 is on. If it is on, this is off. First diagram. There will be the rectification, and what will be the output? Output is exactly replica of the input but with 180 degree phase shift. So output will become minus 1 by 1. This is the minus 1 by 1 into VI. That is the minus VI. That is minus 5. If it is plus 5, output is minus 5. Okay. Yes, you are giving the right answer, A and D. बहुत बढ़िया. And when it is minus 5, what about the VA? It will be the positive value. Once it is positive value, D1 is off, D2 is on. Once the D1 is on, output will be 0. Because the rectification is the duty of what? This diode. Rectification is the duty of this diode, and this diode is off. The output will be 0, and this diode is on. And what is the duty of this? It will avoid the saturation of the diode. It will avoid the saturation of the diode. It will provide the negative feedback. It will reduce the PIV, peak inverse voltage. New student, you can watch my lecture on that, precision rectifier. I have explained each and everything. Now A is the correct one, D is the correct one. You have given the right answer this time. Okay, okay, good one. Next question. ठीक है भाई, सबको एंजॉय कर रहे हो आप लोग सेशन? हाउ इज द जोश? एक बार हार्ट, दिल विल सब तो भेज दो. ये से तो मैं डिमांड करता नहीं. बोला बताइए. यस, एवरीथिंग इज फाइन नाउ. ओके, डोंट लूज योर कॉन्फिडेंस, राइट? बिकॉज नाउ वी हैव ओनली 2 days. प्लीज एंजॉय द सेशन एंड सिंपली एंजॉय द जर्नी ऑफ दिस प्रिपरेशन. ओके, तो कोई भी 2 दिन में ना डीमोटिवेट मत होना. कोई भी, देयर शुड बी नो नेगेटिव थॉट्स. जो पढ़ चुके हो दैट इज मोर देन सफिशिएंट, राइट? एंड वी हैव टू परफॉर्म इन एग्जाम. तो सेट योर माइंड अकॉर्डिंग टू योर सेशन, फोरनून सेशन और आफ्टरनून सेशन, एंड देन प्लीज एंजॉय द सेशन. ओके, बस ये जस्ट एंजॉयमेंट के लिए, ये इससे कोई ऐसा नहीं, इसलिए मैंने कोई बहुत दीज आर द लाइट क्वेश्चंस, राइट? ओके, बट वी मे एक्सपेक्ट दिस टाइप ऑफ क्वेश्चन. The input signal Vin shown in the figure is 1 kilohertz. Now that is the question on what? BJT, but it is a basic concept of power amplifier. This type of question in what? This is a very very important one. But again very easy. The input signal is shown in the figure is 1 kilohertz square wave that alternate between +7 and -7 with 50% duty cycle. Both the transistor have the same current gain, which is large. Beta is very very large. The circuit delivers power to the load RL. Circuit deliver power to the load RL. What is the efficiency of this circuit for the given input? Closest answer. What is the efficiency of this system? Right? What is the efficiency means what is the DC power available at the output and what is the power actually delivered to the input. Right. Okay. Now tell me how to solve this question. First of all, what is given input? Square wave. 7 minus 7, 7 minus 7, 7, 0 minus 7, it is given. So what is the swing of the input? 14 volt. Okay. Now, this is the input, 50% duty cycle, 7 volt, it is given. You have to find the efficiency. So what is the, remember, what is the formula for the efficiency, everyone? First of all, efficiency is given by output power delivered to the load divided by what? Output AC power delivered to the load, output AC power delivered to the load, this is the AC power, upon what? DC power available at output. Available at output. That is the efficiency. Output power delivered to the load upon what? Efficiency. Okay. Oh. Now, how we are going to solve this? We can solve, first of all, we have the two signal. To let the first signal positive 7, because in a positive half this is a positive signal. Like, try to understand how we can find this. Let this is the 7 volt for positive half. Tell me, if it is a 7 volt, this is the PNP transistor, this is the NPN transistor. So for 7 volt NPN is on. What about the PNP? It is off. When this is on, what is the drop here? 0.7 volt. So what is the output voltage? What is the output voltage now? What is the output voltage now? 7 minus 0.7, the output voltage is 0.6 volt. Seven minus 0.7, that is output is 6.3 volt. 6.3 volt, because this diode is off, remove this diode. 7 minus 0.7, 6.3 volt is the output voltage. Okay. Then at the same time, what is the current here? IC. The same current will flow from this point to this point to this point. And that is the path of the current. Or IC or IE equal, because beta is very large, IB is negligible. What is the value of the IC? IC is given by V naught by RL. 6.3 divided by 10, that is the 0.63 ampere, because it is given in ohm. It is given in ohm, that's 0.63 ampere. Right? Right. Okay then. This is our last session for our gate preparation. Yes, definitely guys. Uske baad सीधा directly for what? Analysis. We are waiting for you. Okay. तो आप आइएगा for analysis then. Then this is the 0.6.3, 0.63 IC. If you know the IC, you know the V naught. In second case, when it is minus 7, what is this? This is off. This is on. If this is on, always remember VEB. VEB will become 0.7 volt. VEB will become what? 0.7 volt. Now write down the KVL, my dear friend. So you have to write the KVL like this. From this point to this point to this point. When I am writing the KVL, what is the V naught? V naught will become plus 0.7 minus 10 minus 7 minus 6.3 volt. Minus 6.3 volt. In that case, what is the value of IC or what is the value of IE? What is the value of IE? Because this time this transistor is off. Again you can find, this is the reverse value, means you can find, this is the positive value of I, no problem. It will be delivered by this battery. So what is the value of the I? In the same direction you will get V naught divided by RL. 6.3 divided by 10, that is 0.63 ampere. Okay. Now finally, you are giving this type of input. And you are getting this type of output. Same square wave. 6.3, 0 minus 6.3. And what is the actual input? 7, 0 minus 7. This is reduced by what? This value. Okay. Tell me, what is the RMS value of the square wave? That is the concept of signal and system. What is the RMS value of the square wave? Because you have to find the PAC. What is the output AC power? Output AC power is I RMS square into RL or V RMS square upon RL. That is the formula. So what is the RMS value? 6.3. For square wave, that is the RMS value. Peak value is called RMS value, 6.3 volt VM. So what is the AC power output? 6.3 square upon what? 10. This is the AC power output. This is the RMS value of the output actually. And RL is given as 10 ohm. So that is the AC power output. Now my dear friend, what is the important thing? How we can find the DC power? DC power means what is the power delivered by this DC battery at the output, because this DC value will provide the IC. At this instant, what is the DC power? DC power is nothing but value of the DC battery current provided. So what is the value of this DC battery? This is the DC battery that will provide you the current IC, 10 volt. What is the current provided? 0.63. So it will become 6.3 watt. 6.3 watt. That is the DC power. Right? Now, okay, this is the DC power provided. Similarly, in the second instant, at this instant, again, what is the DC power provided by this battery? This is the DC value and this is the DC current. Again, we are going to get the same power. VDC into IDC. 10 magnitude. You have to use the magnitude into 0.63 ampere. Same current is provided, 6.3 watt. We are calculating power at particular instant. So at a particular instant, what is the power given? 6.3 watt. What is the final efficiency? AC upon DC. What is the AC? This is the square upon 10. This is the AC power upon DC power. What is the DC power? 6.3 watt into 100. This 6.3, this 6.3 is cancel out. This cancel out. What is the efficiency? 63%. Efficiency of the system is what? 63%. 63%. Okay. Class B, Class AB, Class C. Anything is mentioned here? Everyone tell me. Class AB, Class C, Class D. Anything is mentioned here? That is the question on what? What a Class B amplifier. Complementary symmetry push-pull power amplifier. But they will not give you any value and so on. It is a very easy question on concept of what BJT. Whether it is in syllabus, yes or no, we have no idea. Power amplifier, it is not in syllabus, but they can ask this type of question, yes or no. That is simple question. Okay. Now, last two question. Okay. Ready? This is the very, very important one, 63. Because you will get the idea how to find the RMS value, VRMS, how to find the power, AC power. What is the meaning of the DC power available at the output? This is the DC power available at the output. In this way, proper waveform, proper RMS value, and then you can find the answer. No. If the efficiency is what? More than 50%, that is the 78.5%. Actually, it is a maximum efficiency of Class B. And for Class A transformer coupled, it is what? Class A transformer coupled, it is 50%. A maximum. And Class B, Class A direct coupled, 25%. And for Class C, the amplifier is very high. Okay. Now, 1 minute. One question. Well, first of all, solve this question on MOSFET, then we will solve that question. Okay. Tell me what is the answer for this one. Figure shows a discrete common source MOSFET amplifier utilizing the drain to gate feedback biasing arrangement. And then they will give you the diagram like this on MOSFET, because MOSFET is a very, very hot topic, right? Very important topic, right? Tell me. Figure shows a discrete common source MOSFET amplifier utilizing the drain to gate feedback biasing arrangement. This input signal Vi is coupled to the gate via a large capacitor. This is a large value of the capacitor. What is given here? Infinite. Means during AC analysis, it will act as short circuit. It will act as short circuit. And the output signal at the drain is coupled to the load resistance RL. RL is given here. Another line. We wish to analyze this amplifier circuit to determine its small signal voltage gain. What is the small signal voltage gain? We have to find the small signal voltage gain. You have to find the small signal voltage gain, its input resistance, and the largest allowable input signal. The transistor has Vt is equal to 1.5 volt, Kn dash W by L is equal to 0.25 milliampere, Va is equal to 50 volt. Assume the coupling capacitor to be sufficiently large so as to act as short circuit of the signal frequency of interest. That is a very big question, but only one thing is important. What is the voltage gain? Midband voltage gain. Then, this is a question on MOSFET. Now, try to understand. If you want to find the gain, you have to draw the small signal model here. What is the small signal model? GM VGS. small RD, and that is called small signal model. This is the drain and this is the gate, and that is connected. This is the source, right? This is the source here. Okay. Now this source is connected to ground. Source is connected to ground. Directly this is connected to ground. RG, this is the RG connected between gate and what? Drain. RG connected between gate and drain. And this is the value is very, very high. What is the value? 10 mega ohm. 10 mega ohm. Now here input is connected. This capacitor will act as short circuit, and that's why it is input is connected here. So the gate terminal input is connected here. From drain to ground, 10 kilo ohm RD, from drain to RL is connected. Right? And that is the diagram. Now, my dear friend, if this is given, RG is given, this is called a small signal model. Okay, we have to find the approximate answer. Because this is very, very high, we have no idea about the RD, but you can find the RD. Why? Because early voltage is given. Early voltage is given in the question. Early voltage VA is equal to 50 volt. Then you can find the value of RD. Okay. Then you have to find capital RD is given as 10 kilo ohm. RL is given as 10 kilo ohm. 10 parallel with 10, it will become 5. But you have to find the RD. Now, normally this current will pass through this resistor. Combination of this resistor. What is the current through this RG? Negligible, because the value of this resistance is very, very, very high as compared to what? This one. And that's why current is negligible through this. We can neglect this current, and approximately you can write the V0 by Vs. Vs is nothing but VGS. Vs is nothing but gate and source. That is the voltage between gate and source, VGS. So you can write minus GM VGS RD parallel with what? RL. Upon what? VGS. VGS cancel. You have to find the minus GM RD parallel with what? RL. You have to find this value only. That is a small signal model. Okay. We have any idea about the what is the ID and how to find the small RD? Then, my dear friend, no doubt, it is the gain minus GM. We have to find the transconductance. How we can find the transconductance? Again with the help of ID. So first of all, DC analysis. In a DC analysis, capacitor act as what? Open circuit. Remove this capacitor. Remove this capacitor. Remove this two capacitor. Okay. And then guys, it is in saturation definitely when the drain is connected to source. When the drain is connected to gate, drain is connected to gate through RG. Then definitely it is in saturation. Ig is equal to 0. This VDS is equal to what? Become VGS. And what is the VDS? 15 minus, what is the current here? ID. 15 minus ID into RD. Or what is the value of RD? 10 kilo ohm. 15 minus 10 times of ID. Okay. So during DC analysis, capacitor will act as open circuit. This is connected here. For which? Mu and Ux. Okay, 1 minute. This is the ID. Right. Now, my dear friend, this is the VD and this is the gate. RG is equal to what? There is no current, and directly VDS. When the drain is connected to gate, always it is in saturation. First of all, find the value of VGS and VDS, 15 minus ID. Now write down the equation. ID is equal to half of K and S, W by L, VGS minus VT the whole square. Now my dear friend, ID is equal to half of into what is the K and S W by L given in the question? K and S W by L 0.25. VGS means VDS. What is the VDS? 15 minus 10 times of ID minus VT 1.5 volt it is given. Okay, this is a quadratic equation. How many students are able to solve this? I am not going to solve this. You can solve this quadratic equation. Okay, try to solve. I am going to give you the answer only. And with the help of quadratic equation, you will find 1.06 milliampere. 1.06 milliampere. Right. Once you will get the ID, from this you have to find the VGS. And this VGS should be greater than what threshold voltage? Should be greater than threshold voltage, because you will find what? Two answers. So what is the second one? You will find the VGS is equal, VD is equal to 4.4 volt. VGS is equal to VDS is equal to 4.4 volt. Okay. Right. Now, last question, and then just 1 minute. I am going to give you the password. VGS is equal to 4.4 volt. Once you have the ID and you have the VGS, finally, what is the gain, my dear friend? You have to find the GM then. GM. K and S, W by L. VGS minus VT. This is the value of the GM, transconductance. What is the transconductance? 0.25. 4.4 minus 1.5. You will get the transconductance. Find the value 0.725. 0.725. Okay. And this is the case. GM, milliampere per volt. Now, GM is known. Finally, you have to find the idea. RD, VA, 50 volt it is given, divided by what? ID. ID you have calculated 1.06. Find the value of small RD, 47 kilo. My dear friend, if I am using the resistor, what is given? What is the unit here? Given as milliampere per volt, and that's why you are not going to get the mho, Raghuram. You are not going to go mho. It is what? Millimho, millisiemens, right? Milliampere per volt. Remember, this is the unit. You have to consider the unit also. Now, once the GM is known, RD is known, capital RD is known, capital RL is known, you can find the gain now. You can find the gain now. Put the value of the GM, put the value of small RD, that is the 47 kilo ohm, 10 kilo ohm, 10 kilo ohm, all are parallel, and you can find the gain, that is called midband voltage gain, around minus 3.3. Minus 3.3. Is it clear? This is clear. So, what is the special in this diagram? We have to consider the early effect, or that is the VA, during what? AC analysis. But we are not considering the early effect during what? DC analysis. So no need to consider it. Otherwise the question will become very, very lengthy. Question will become what? Very, very lengthy, my dear friends. So it is approximate. Definitely in a GATE exam they will give the answer. Approximately find the value. Hope so you are enjoying the session. Last but not the least, and the password, right? Password for this session. Okay, note kar lijiye. Last question, please give me the answer also. MOSFET, right? MOSFET 11. Sometimes because password na 8 word is required to MOSFET 11, because it is a Super 11 series, MOSFET 11. Okay, and that will be the password. Normally they are not considering the early effect for what? Electrical stream. Yes, but they will ask here any type of question, right? Yes, please. Last one, last but very important one, and thank you for your cooperation here. Pura raat ko pura 2 ghante ho gaye, right? Thanks. The circuit shown in the figure is intended to supply a voltage to floating loads. Where is the floating load? Not connected. Here we will connect a floating load. Floating load means no terminal is connected to ground. If the one terminal of the RL is connected to ground, then it is called grounded load. No terminal is connected to ground, that is called floating load. It will connected between B and C, but RL is not given. While making the greatest possible use of the available power supply. Greatest use of the available power supply, we are connecting like this. Okay, so that we are going to get the more link. Okay, I will share the link also. So tell me what is the answer for this question, everyone? Very, very easy one. Last one. Last question, tell me. अरे अभी बोलिए जरा. I am here, everyone. A Telegram channel is link is also given in the description box, or you can join by this time. I will upload this on Electronics by Sanjay Rathi. Right, I have given the link. Okay, everyone please join that, and just after the session I will upload. Okay, and then the circuit shown in the figure is intended to supply a voltage to floating loads while making the greatest possible use of the available power supply. Okay, that is the question on operational amplifier. Right, you are giving the Ravi Teja, you are giving the 6 or 0.6. It is 6. Okay, now by this type of question, very, very simple one, try to understand. If this is VI is connected here, right, if the VI is connected here, then means in this terminal, the voltage is VI. That is a separate diagram. It is a non-inverting operational amplifier. Or in this terminal, it is connected here, it is a inverting operational amplifier. What about this resistor? Because there is an ideal condition, no current, no need to consider this drop. Similarly, what is the current here? Zero current, because the input resistance is infinite. So what is the voltage at this point? VI. No need to consider it. It is a non-inverting operational amplifier. It is an inverting operational amplifier. So what is the gain for the inverting operational amplifier and non-inverting operational amplifier? Okay. For this, the voltage at the B terminal will become 1 plus RF1 by R1 into what? VI. And what is the VC will become minus RF2 by R2 into VI, because VI is same. So what is this? It will become, VB will become 1 plus 20 by 10 into VI. That is nothing but 3 VI. And the VC will become minus 30 by 10. 30 by 10, that is the RF by R2 into VI, that is minus 3 VI. Okay, now what is the actual output? What is the actual output? VB minus VC. Now here the student will make the silly mistake. VB minus VC is equal to 0. No, VB minus VC means what? 3 VI minus of minus 3 VI. What is this? 6 VI. 3 VI minus of minus 3 VI, 6 VI. So please try to avoid the silly mistake. Once you will get the V0, so what is the V0 by VI? V0 by VI will become 6. V0 by VI will become what? 6. Okay guys, this is the answer for this question. We can increase the swing of the output. That is the beauty of this diagram, because what is the maximum output supply voltage? Suppose the supply voltage is given as 15 minus 15. So what is the highest voltage? 15. What is the lowest voltage? Minus 15. So what is the swing will become? Swing will become what? 30 volt. Highest and what? Lowest. What is the maximum voltage we can get? 15 minus of minus 15, we can get the maximum 30 volt. Maximum 30 volt. Otherwise, in one operational amplifier, we can get maximum voltage 15, lowest value minus 15. Here you can get the maximum voltage 30 volt, lowest voltage minus 30 volt. Are you getting my point, everyone? So they will ask, what is the range of the output? Range of the output, maximum range of the output. So in one operational amplifier, we are saying that from 15 to minus 15. What is the range of the output? From 30 to what? Minus 30. 30 to minus 30, double. This point is clear? This point is clear? Right? This is the last one. What is the highest value of this? 15. What is the lowest value of this? Minus 15. So what is the total range? What is the V0? 30 volt. Similarly, what is the lowest value? Minus 15. What is the highest value? 15. So what is the total range? Minus 15 minus 15, that is what? Minus 30 volt. highest value 30 volt, lowest value is minus 30 volt. Yes, so that is what is written in this question. The circuit shown in the figure is intended to supply a voltage to floating loads terminal while making the greatest possible use of available power supply. What is the available power supply? 15 and minus 15 volt. Okay, so this is all about this session. अरे डोंट वरी रघुराम, अभी ना जस्ट गेट पे फोकस करो. दिल IRMS तो ठीक है, नोटिफिकेशन आया है ऑलरेडी. आई हैव मेड वन सेशन ऑन दैट already. I have given you the detail about that. Okay, don't worry. But now we have only 2 days. Okay, please simply focus on the GATE exam, give your best. After that we will prepare for what engineering services exam, and then we will make a proper plan for that, right? We will use our all technical knowledge. Don't worry. बहुत सारे यार अभी तो बहुत सारे ऑप्शंस आएंगे. आप टेक्नोलॉजी सीखोगे, बैटरी बनाओगे, तो नॉलेज कभी वेस्ट नहीं होता भाई. जॉब लग गई तो बहुत बढ़िया, नहीं लगी तो उससे भी बढ़िया. यस और नो? इफ यू आर गोइंग टू गेट द जॉब, वेरी गुड. इफ वी आर नॉट गोइंग टू गेट द जॉब, अगेन एक्सीलेंट, बिकॉज नाउ वी कैन गिव द जॉब. ओके, तो विद दिस टेक्निकल नॉलेज, तो विद दिस पॉजिटिव माइंडसेट ट्राई टू गिव द एग्जाम. Definitely you are going to get the good result. So BYJU'S exam prep rank predictor tool, you can get the rank here, like that is live from 15 Feb 2023. Know your GATE 2023 rank and plan ahead, right? So please subscribe our channel, register here on our app so that you will get the notification about detailed about this rank predictor, right? And then take a step towards success in GATE. Get up to 90% scholarship on preparation program. That is the scholarship test on 7th Feb 7:30. Please ask your junior to join this scholarship test. जितनी जल्दी तैयारी स्टार्ट करेंगे उतना बेनिफिट मिलेगा. ओके, तो इफ यू आर एंजॉयिंग द सेशन, तो गिव द राइट सजेशन टू योर जूनियर्स एज वेल एज फॉर GATE 2024 and 2025. And that is the, and you are on BYJU'S exam prep. Thank you for your support. And my dear students, enjoy the session. Right, like the session, share the link of this session, and most important one, good luck for your exam. फोड़ के आना है भाई, पूरा परफॉर्म करके आइए बेस्ट तरीके से. Right, right. Only formula notes. Now it is time to revise your formula notes and short notes only. And for link, you can scan this QR code. Thank you and good luck. Thank you and good night. Guram, I will ask to upload the marathon session network. Okay, PDF for that. I will upload this PDF. Okay, then thank you.